Hello, Forecaster here again, and we are back for the third and final part of the Railcraft routing tutorial. And in this part, we are going to have a look at regular expressions. So, regular expressions is a system used to match text strings according to a pattern, and it is a standard across many different programming languages, including Java, of course. So Railcraft allows you to use regular expressions to match destination strings. So that is what we're going to do in this episode. So here we have a train, or a locomotive, set to home/lime. Over here, we have a switch that goes into home. So in this switch, we are simply going to have a routing table that says home, which is of course going to match the first part of this string, as we have seen before. Now inside of home, we have two sub-destinations, lime and blue. And we of course want this train to go into lime. Now to do that, you would normally do dest equals home/lime. And this would of course work because it matches this destination string exactly. However, we're going to do this using regular expressions instead. So we're going to get rid of all of this. Now, if you want to use a regular expression, you're going to want to do dest question mark equals and then your regular expression. So the question mark before the equal signs tells Railcraft that this is a regular expression instead of a normal string. Now, if you want, you can just do home/lime here as well, and this will work fine. Because the regular expressions will be looking for this exact string. Now, that would be kind of a waste, though, because regular expressions allows us to substitute certain characters for generic symbols that will match specific things. So, for example, the period in regular expressions will match any character or symbol. So a single period will match one letter, number, or symbol. Two periods following each other will match two characters. So if we simply enter in 4 periods, this will match 4 of any characters, which happens to be the exact length of the word home. And then of course we have the /lime, which matches the remainder of the string. So if we put that in there, then we are going to send this locomotive, and of course that switch worked. And then as you can see, it also matched this one. Now I'm going to put a buffer stop here to keep the train from going all the way back when I do this. So this regular expression I just wrote matched this string, even though it doesn't actually say home in here. So these 4 periods will match each of these 4 letters here. However, if I were to add a 5th period here, this is also going to match any character, of course. The problem comes when it goes through this regular expression. It's going to match the first period to this H, second period to the O, third period to the M, and the 4th period to the E. Then the 5th period is going to match this slash. And it's all fine up until now. Next, however, we have an actual slash, which is going to be where this L is. And this L is not going to match the slash, of course. So here's where the regular expression is going to fail. Now it's still valid, of course, but if we send this train down here, it is not going to be routed in because it no longer matches the regular expression. However, if I were to take this destination string and add a second letter before, or an additional letter before the slash, and update that, it is now going to match the routing table again. So doing this, we can match any string of a certain number of characters or of a certain length without actually specifying what it is. Let's restore this because it looks wrong. So what if we want to match a string of any length before the slash lime? To do that, we can use a quantifier. So regular expressions have a number of different quantifiers, and a quantifier is a special character that tells the regular expression or gives the regular expression a special instruction. So if we enter a period, which will match any character, number, or symbol, and then follow that by an asterisk. The asterisk is our quantifier, and the asterisk tells the regular expression to look for the previous character, which in this case is any, and it will look for 0 or more. So essentially any number of characters. So now, no matter what is before the slash lime, it will always match this routing table, no matter what it is or how many characters there are before. So if we accept this, put the routing table in there, and then turn this, it is going to match the string. If we add something, say we do home slash lime, which is now twice the length, it is still going to match. However, if we were to add something behind, say we do that, if we add something behind the slash lime, it is no longer going to match the routing table. So if we have a look at this, the regular expression is looking for any number of any characters and then slash lime. And then it expects the string to end. And since it doesn't anymore, it will not match this regular expression. Now to fix that, we can simply add another period and another asterisk after our slash lime. It will now look for any number of characters before slash lime and then any number of characters after. And of course include none. So if we put this in here and then turn this back, it matches. Then we can get rid of the slash blue again, put that in here, and it's still going to match. Now there are more quantifiers we can use. to be more specific. So there are two more characters that are quantifiers. So we have the asterisk, which is 0 or more. We have the plus sign, which is 1 or more. So the plus sign will expect there to be at least one character. So if there are none, so for example, if we were to replace this asterisk here with a plus sign, since the string ends after /lime, and this would expect there to be at least one more character, this would fail. And finally, we have the plus sign, which is 0 or 1. Pretty simple. We then have a dynamic quantifier, and it is two squiggly braces, which we then can put numbers in. So, for example, if we put a 4, it is going to expect exactly 4 of the preceding characters. So if we were to do this, this would basically be equivalent to this, which is 4 periods. Of course, that's not the only thing we can do with it. We can enter a comma and then a second number, and this will expect between 4 and 6 of the preceding characters, in this case a period, which will be essentially equivalent to one of these. So we have 4 periods, 5 periods, and 6 periods. So any of these will be equivalent to this. However, if we were to have 7 periods, I think that's 7, this will not be the same as this because we have an additional period. It would, however, be equivalent to this because we now have an unquantified single period after our 4 to 6 other periods. As I said, regular expressions can get pretty complicated and can take a while to learn how to use them. But these are our quantifiers. Now, I'm not going to go too deep into this. If you want to learn how to use regular expressions, I would suggest finding web resources to teach you. There are also web applications that allow you to write regular expressions and see their result on a test text immediately. Which also, and they also have quick references which lists all of the different quantifiers and other things you can have. And one of the ones I like to use is called regex101.com. It's a fairly good one, and I would recommend it if you want to learn how to use regular expressions. Now, finally, we're going to have a look at an interesting problem that someone came up with, or more specifically, a question I got asked. So, Railcraft doesn't allow you to compare numbers in destination strings. Specifically, I got asked to how to check for a higher or lower than a specific number. And Railcraft doesn't let you do this, and unfortunately regular expressions doesn't really let you do this either. However, there is something that can get you sort of close. So as you can see here, we have 3 different locomotives, and they each have the string express followed by a number. And we have 3 different numbers here, as you can see. Now, if you want to separate these, we can use regular expressions. So we have the string express, of course. Now, if we wanted to match any number after the express, we could simply do this, which would also match any letter, of course. If we want to match numbers specifically, we can do 2 square braces and then put 0 to 9. Now, these square braces allow you to specify a character set that is going to match or be checked. So currently, we have any number between 0 and 9. You can also do square braces A to Z, which will of course match a letter, any letter between A to Z. And you can of course do any range you want, so G to L, for example. And this will match a single number and not multiple. So this is going to match express 5 only, because these two, it would match up until the first number, but then there is a second number, and as you can see here, the string ends after one number, so these will not match. Now we can match, of course, any number of any length by adding an asterisk, or we can match just 2 numbers by doing squiggly braces with a 2 inside. This will match only these 2, of course, because this only has a single number, and we're looking for exactly 2. If we wanted to match all 3, we could do 1, 2 inside of the squiggly braces, and this will match 1 or 2 numbers, and both can be between 0 and 9. Now, if we want to be more specific, we can do something like this. So, for example, if we only want to match the express 15, we can of course either do express 15 exactly, but say we want to match anything that is 10 or higher. What would we do then? We'd probably want to do this. We would want 0 to 9 for the first number, and then for the second number we want 0 to 9. So this includes these 0 for the second number, but not for the first. So if we had an express that was, if we had a 0 before the 5, this would not match because the first one needs to be 1 or higher. Then the second number can be 0 or higher, but there has to be a number there, so it will not match this first one. But it's not going to match if we had an express 100, because that has 3 numbers and we are looking for exactly exactly 2. So if you want to do that, you would have to do another one of these, like so. But this would always look for 3 numbers. So if you wanted to this to include this, you would have to add a question mark here, because as you might remember, the question mark looks for 1 or 0 of the preceding character. So there doesn't have to be a third number. So to demonstrate, or to check if this works or not, we're going to add a second or a fourth train here, and we're going to change it to say express 100, like so. And then we're going to set all these to a reasonable speed. So the express 5 is not going to match, of course. It's going to go straight. But the express 10, 15, and 100 are going to match. So if we that is odd. Right. So let's send these back. Now let's adjust this so that say we want to exclude the express 10. Now we can't really read them. There we go. That'll do. So now we want to exclude the express 10 and 5 from the roundup. So we want to match 15 or higher. How would we do that? Well, we would simply change this to there we go, 5 to 9. So the second number has to be 5 or higher. Now, you'll notice a problem with this. This will not match any even increments of 10. So this will no longer match 10 because this can't include 0. But because this cannot include 0, it will not match 20, 30, 50, or 60, or 70, 80, or 90 either, because the second number cannot be 0. So there are some limitations with this, and there's no real way to work around that, because regular expressions were not made to compare or do mathematics in this way. But now the switch, expected it to match the, yes, they won't match 100 either because the second number here is 0. So regular expressions were not made to do this. You can sort of do it, and this is probably the best approximation of this that I could come up with, unfortunately. Maybe make a future request if you would want to have an actual way of comparing numbers in destination strings in Railcraft. That would probably be a lot easier than trying to use regular expressions to do it. So yeah, so this is going to be the end of the routing tutorials for now. So I will see you in the next video.